A lot of tongue twisters in today's tutorial. Today we are looking at how to take a single video input, track 3 different colors in it, or in this we've just got the primary colors, and then use those values or use certain values output by it to make some music. So in this particular case, someone was asking how they could use a single video to track multiple colors and then with those multiple colors produce music. I'm not going to go into any detail about the music production because that's just not my field. You know, I always say I'm a jitter man rather than an audio man. But what I do use is some simple 30-second loops that I created years ago are controlled gain-wise by the values that we get from our video. So if I turn it all on, what the patch is doing, it is tracking red, yellow and blue, dividing out its area, so working out the area of the tracked space, and then with that tracked area it's working out a percent of the screen that is covered by it, or a percent of the 3 colors that are covered by it, and then raising or lowering the volume depending on that. And you can see over here I've opened up the red patcher. We are using the CV, so computervision.jit library, and the centroids and blobs. So what's happening is we have our video coming in, we change with its, we use some operations to change its values so that the color we want to track appears as white. We pass it through some thresholds, and then we use CV.jit blobs to then pick out anything that is that color. In the example I'm using in this video that I got, it only has one red, blue and yellow patch, but CV.jit.blobs will track as many different color patches or different sections of color as you want. So if there was red here, here, here and here, it would all be tracked. And then we use jit.iter to get the data for that tracked section, and then depending on the iter that you use, you can get the data for the first, second, third, fourth, fifth, sixth, seventh tracked patch. And what cv.jit.blobs.centroids output is the X, the Y and the area. So we have the center point of the mass and the area in, it's a nonsensical number, it makes sense in between each other. And then what we have it doing is it brings in the 3 values, adds them together, so we have a total area, a total color area in the patch, and then it works out what percent of that total color area is being covered by each color. A lot of tongue twisters in today's tutorial. And then that value, so the percent value, is scaled to give us a gain. So each of these 3 different sounds, I've just got a synth, a sub bass and some bells ringing, they change gain in depending on how much is being covered. So as this video loops and loops and loops, the amount of noise will change. Now to try and keep the time down, what I'll do is I will show you how to create one of these 3 patches, and then so all I do is I make one, encapsulate it, and then all we need to do is change this value here to control the color it's searching for. So you can see in red it's that. If I bring in blue, you'll see that it's the exact same patch. It doesn't have the visualizer because we don't need it, but it's got a different color value. Simple as that. So I'll get rid of all of that for now, and let's get to work. So first thing I'm going to do is, normally I would make a new patcher, but I'm actually going to make a new project. And yeah, so I'm going to call this multiple color tracker. And there's a few things we're going to need here. First thing I'm going to do is make a new file, and I'm just going to make the match patch and call it main patcher. And then that will create our patch. I've also got a couple of files I want to add. So the first thing is I have these 6 audio files. I'm going to copy them over just because we'll need them later. I'm just going to create project local versions of these as well so that we can reference them straight in without needing file paths, which is beautiful. And then I also have downloads primary colors. And I'm going to change the name of this, create project local version, reveal in Finder, and then I'm going to call it PCA just so it's a bit neater, and I'm going to add that. and remove from project. So now I have my patcher, my main patcher, and all the files I'm going to need to create. And in a real simple way, that is how to make a Max project as well, so we can reference internally. So in my main patcher, let's get started. As with everything, we're going to start with a toggle and a metro 30. You can bring this in on live camera footage as well. That's where I've actually used this in the past. So I had a webcam above coloured Lego blocks, and the Lego blocks were allowing users to make music. But for this, I am just going to use a JIT.movie. And because we made it local, we can now read PCA.mp4. I'm also going to add a use rc-rect1 here. You don't need to do this, I just know that there is a black border on this video, so I'm going to use values that I worked out previously so that it fits nicely. And I'll show you what that means in a minute. So if I just get rid of that, P window, so if I read that, you'll see that there's black borders either side of that. So what I do is I use source dimensions, and that just lets me stretch it a bit so it gets rid of those black borders. Wouldn't cause any issue at all, but it's just much neater. It's for me. I worry about it too much, because when we're actually setting the color value to be white, it'll ignore those black borders anyway. So that's just got our source of color, which is beautiful. Next I'm going to do is I'm going to pass it into a trigger list. And the reason for that is that the CV, the computer vision library, can be very intensive on the CPU. So I'm going to downscale the entire matrix so we have a very, very low res version of this. And we're going to use that to do all our calculations. So I'm going to do JIT.matrixInfo. I'm going to route the dimensions into a V expression, so we're going to express on a list. I'm going to do I1 divided by 10 at scalar mode 1. And what this is going to do, it's going to take our matrix and basically divide it by 10 neatly so that it's 10 times smaller. And this is a fairly small movie already, but it's just this is a nice trick to remember for future if you're finding that your video processing is slowing everything down. And I'm going to prepend dim again, so I'm going to tell it's a dimension again, JIT.matrix adapt 0. So putting on the adapt 0 here means that from now on, when we re-trigger this matrix, it's not going to readjust back to its automatic, back to the full size, as is the way with matrix. So JIT.movie is automatically sizing to this file. JIT.matrix would always automatically do that as well if we didn't do adapt. And just to show you what that looks like, you can see it's just a very, very pixelated version of the same movie. And because we only want pure color, that is perfectly fine. Now, I already know color values for the colors in this video, but if you didn't, you would need a sucker. And simply a sucker into a message box. And we want the old style 255s. Simple as that. So I'm going to click here. So that's my red value. That's my blue value, and that's my yellow value. So I'm going to do red, blue, yellow. And the method that I'm using requires an alpha channel at the start. So I'm going to add a 0 to the front of all of these, just so that we are ready to go. So we know that I've got my red, blue, yellow, so I'm going to store these over the way. We technically don't need this anymore, but it's just nice to have there in case you want to make any last minute changes. Let's make our color tracker. So I am going to do a JIT.op operator at operation ABSDiff, absolute difference, at val. And I'm not going to put a value after val because we're going to input that with our color. So let's bring down our red value. Let's prepend val. So now we should have a message that says val. Perfect. We plug that in. I'm going to bring down a P window just to visualize this for you. So you can see that nothing's changed. We prepend val, and what it's doing is it is going to turn the color we want to track black. This might seem odd, but you'll see why in a minute. We're then going to do jit.op at op abs diff, absolute difference again. And this time I'm going to do at val 255. And this is going to turn any blacks white. So again, visualize it for you. So what this means is the color we want to track is now white. And from there, we are going to open up the C. I'm just going to stop it for a minute before it gets angry at me. CV.jit.blobs.centroids. And let's have a look at this. So what the CV.jit.blobs.centroid does is it essentially tracks whatever the value under our threshold is, and then it gives us the X, the Y, and the area coordinate for lots of different. So if we use the arrow values you can see here, it is individually tracking these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 arrows, and each of them are outputting different values. And we're going to use that exact same method. And to keep it simple, all you need to know is that CV.jit requires grayscale, so monochrome footage. You add an operator under a value as a threshold to gate your image. And most importantly is it must be labeled with car mode 1, char mode 1, otherwise things will explode. So we're going to put that there. We are going to do jit.rgb to luma to turn our image black and white. So now we have this, so you can see color we want is nice bright white. We are then going to do jit.hop at operator greater or equal to val at val 255. And this is where it gets a bit different from the CV.jit example in HIP. What we're doing now is we are gating everything, and we're going to add a threshold to allow stuff to pass through it. And you can see the difference in the threshold. It allows more of things closer to our red value than not. So you can see there's a nice little bit of what's almost orange between these two shapes at the end here, and we can get that to include it as red if we wanted. But I'm going to turn the threshold quite a bit up to about 200, and that's going to give us a nice really clear reading on our red. So we can get rid of that now, and I'm going to load mess 205 because I know that's the threshold that works for me. And this, you can see, is something you can change in real time. So when I was doing the camera work and the coloured blocks, it was nice to be able to just quickly go into the patch, and if the light had changed, which was a real problem, I could change the threshold and get a much better reading on the colour on the fly. So from the jit.operator, we need to do the cv.jit.label at car mode 1 at threshold 20. I'm not going to go into detail about this, you just need it, otherwise CV.jit.blobs.centroids will not work. It's part of the computer vision library that allows it to label objects. You can see it doesn't actually produce anything. But now, CV.jit.blobs.centroids is outputting some lovely information for us. If we do jit.iter, plug that in, you'll see we are getting a message that has an X coordinate, a Y coordinate, and an area for mass. But the problem with this is it's still scaled down by 10%, or a tenth, excuse me. So we need to scale it back up. So we do another v-explore, if I can type the right keys. Our input times 10. That's scalar mode 1. Now if we plug that in, we will have a real x coordinate, y coordinate, and area for this red mass here. How amazing is that? And you can also visualize it if you use the CV.jit.centroids.draw patch, plug that in, give it our original matrix, give it a window. You'll see that in very, very low resolution, it is tracking our red and giving us the center point for it. And even when it's a tiny sliver, it still tracks perfectly because of this lovely threshold we've got. But you do not need to draw it. It's really, really CPU intensive. And as simple as that, we now have a red tracker. What we need to do is duplicate that, change our value, plug in that, load mesh that. We now also have a blue tracker, and repeat again. And finally, we now also have a yellow tracker. But looking at this, I can see there's a problem because the area of yellow is absolutely massive. And what you'll find is if you do this a lot, is that yellows are a nightmare. Because yellow and white, when thresholded, get disgustingly close together. So I know when I plug this in, I'm going to change this down to, I'm going to change this to my RGB one. So there you go. So it is showing all the white in the area. It's just so we can turn up our threshold a bit. You just need to play with it, and there we go. We get a nice read on the yellow towards the end of the footage. Not so great at the start, but it does pick it up. But it is something you need to play with. I'm not going to fiddle with the threshold forever because I would also go back and change the value of the yellow I've got coming in here because I've clearly not picked this up correctly. So now we're getting a much more accurate reading on an area that you can see that the yellow ends up slightly smaller than the red and the blue, so it does line up with these nonsensical values. And what I'm going to do is, I'm not going to encapsulate it because I'll need to load back now again. So where do we go from there? We turn them into music. So what I am going to do is I'm going to make a new patcher and call it music. And then in here, I am going to put in I'm going to receive red, yellow, blue. I copy these out here. Send, 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 and I'm just going to send the output from our V expression into that. So first thing we need to do is unpack it. And they all have 3 outputs. Oh. And it's x coordinate, y coordinate, area, so you can really do it however you want, but I quite like this method. So I am going to create a expression. I'm going to do float1 divided by, no I'm not, I'm going to do integer 1 plus integer 2 plus integer 3. and that I'm going to add area 1, area 2, area 3. And why is that important? Because that gives us total color area. So we now have a number for all 3 of the areas added together that we can use to work out percentages for each color in that space. Importantly, I'm going to add 1 because we can possibly divide by 0 here. If there's no color found, this will give a 0 value. So to avoid 0 division, sad face. Dividing by 0 is bad. Max won't overflow, but it will get really angry in the max window, the console. And then I am going to expression $ float1 because we are about to divide by a massive number, so we're going to get a decimal by float2. Oh, not plus, divide by float2 times 100. Times 100. So we are going to plug our original value in, divided by our value here, and output we will have a % of the total area that our red color is taking. We duplicate it, plug it into the yellow, and plug it into the blue. And I've just realized what I've done, that I have actually got my yellow and my blue the wrong way round. So you can call me silly. Even wrote red, yellow, blue, but still. Blue, yellow. There's probably an easier way to fix that, but it does not matter. So now I'm getting % for each, and you can see that yellow is always slightly smaller than everything else. And because our track isn't quite right, it flicks to 0 quite a lot. And the good thing about centroids is instead of kicking all loads of fuss, it just says, nope, nothing's seen, 0. So it's not tampering with our values too much. This does mean that we'll probably see spikes in volume for our red and blue though when yellow is not seen, but you can play about and compensate for that yourself. So that's the way I'd do it. If we look back at the original thing, I'm not going to show you how to play files and things, but I scale it down so I know that this value is only possible between 0 and 100. And I set that to a gain level where it spikes up and down depending on what we're hearing. All you need to do is open the file that we've included in our project, and this smov is smooth. It's part of an external package that it smooths numbers on the fly, so it's like a line but without needing to bang a time into it. I suggest you check it out. I'll put the link in the description below. But there's a quick look at how to get values out of multiple colors from a single video. I hope you enjoy it, and I'll see you in the next one. Keep sending me your questions and your ideas. My email address is in the description, and I like to take your ideas and what you're struggling with and turn them into videos to help you out. Cheers.